Okay, I'm going to go through the next few slides a little faster. The clear method clears the list. It essentially removes all the elements. It's implemented here by reinitializing each of the fields to their initial values. And as you can see, if you go back to look at the code, it's the same code that the constructor has. The contains method returns true if the list contains the specified element. If the element is null, it just returns false. Otherwise, it loops through the array to see if the element's there. Note that it's just iterating up until size, because all of the cells in the array after that are unimportant. They don't represent elements of the list. And here are some visual comments. Okay, the equals method tests if two lists are equals. The interesting thing about this method is that it will work even if the other list is not an array list. For example, the code will work just fine if the list being compared is a linked list. As long as they're both lists, their sizes are the same, and their corresponding elements are equal based on the equals method, the lists are considered equal, and this method is going to return true. And here are a few visual comments regarding the equals method. Okay, the get method returns a reference or handle to the element at the specified index. It does not remove it from the list. We're going to see a different method that does that. The index of method returns the index of the first occurrence of the specified element. If that element cannot be found in the list, this method will return -1. The isEmpty method just checks if the list is empty, and the iterator method returns an iterator for this list. And here are some visual comments. Recall that the contains method returns true or false depending on whether the element is in the list. You could actually implement contains using index of, because index of is giving you more information, but you can't really do it the other way around. And it should be noted that implementing the iterator interface in Java allows you to use those cool for each loops, or as Java calls them, enhanced for loops. Let's finish up with the remove method. First, we check that the index is in the appropriate range. Then we get the element from that index. Next, we move all the elements that were to the right of the one removed one cell over to the left. We decrement the size and then return the result. Now, if you remember when we looked at the add method, the remove method, and logically so, is doing things in the reverse order. Here it is visually. So when we were adding J at D's position in the same array, I was the first element to move, and now it's the last element to move because things are being done in reverse. And that's it for this module on arrays and array lists. This diagram shows a small subset of the Java type hierarchy. All the arrows you see here are ISA relationships. So, for example, array list is a kind of abstract list. An abstract list is a kind of list. We'll look at this hierarchy in another module, but it lets you see where array list is in the grand scheme of things. In the next module, we're going to get into another major implementation of lists, the linked list. I'll see you there.